I'm going to introduce our speakers tonight. The first is Beth Long. Beth is a project lead for New Relic's collaboration with the SNAFU Catchers project. She has been tinkering with the web since before CSS was a thing. She is currently on New Relic's solutions strategy team, where she builds feedback loops between sales, marketing, product management, and engineering, in particular around how New Relic fits into DevOps and reliability solutions. She reads much of the night and codes into the winter. Tim Tischler is a reliability champion here at New Relic, focusing on the reliability and safety of the RPM website. He's been focused on the partnership with SNAFU Catchers and has been practicing continuous delivery at scale since the era when everybody thought that that was complete madness. So, welcome Tim and Beth, and I'll let them take it from here.
How about that? Oh, there we go. Okay, good.
Now, there we go.
There we go. Almost had an incident. Okay, so thank you for coming out tonight. We're really excited to be talking to you because this is a subject that both of us are really excited about. I apologize for not being Richard Cook. I am very sorry that he could not be here tonight and you're missing out, but we will do our best to channel him and share a lot of the things that we have learned from working with him over the last year. So really quickly, I'll let you bask in the glory of our safe harbor slide, and if we happen to say anything about New Relic that sounds like a promise, ignore us. Okay, so let's get to the good stuff. What do you do when things are on fire? How do you respond? How does your organization respond? We're going to talk tonight about how we deal with problems in complex systems, that is to say, life, right? We're going to be looking in particular at what we do in the tech industry to deal with incidents, but we're going to be drawing on disciplines that have been building on a multitude of industries over the years, the military, aviation, aerospace, transportation, medicine, and firefighting. In fact, one of the people that helped us shape our incident response here at New Relic was a former firefighter and brought a lot of practices from that field into the tech industry several years ago. So firefighters are at the sharp end. Is this a phrase that's familiar to anyone in here? A couple people, okay, cool. So people at the sharp end are the people who are dealing with the dangers and realities of the systems that they deal with. Firefighters are at the sharp end. They're not sitting in an office running modeling on risk factors for the coming fire season. They're on the ground. They're dealing with the blaze in real time. Medical professionals, especially ER doctors and surgeons and anesthesiologists, are at the sharp end of medicine. Richard Cook, who can't be here tonight, but as I said, did a lot of the work that we're building on. He was an anesthesiologist for years and did a lot of research into patient safety. If any of you have read his paper, How Complex Systems Fail, that was actually based on a lot of work in the medical industry. If you haven't read that paper, go home and read it tonight. It's amazing. So we're going to be talking about life at the sharp end and what it means to be dealing with the complexities and realities of these systems. So talking about a specific incident, engineers are at the sharp end of our systems, especially engineers who are on call. Does anyone remember just about exactly 2 years ago, Amazon S3 went down? Yeah, that made an impression on any of us that experienced it. They couldn't even update their status page because their status page, depended on assets stored in S3. So that was an interesting day. I remember it. It was quite a challenging day here at New Relic, although it wasn't as chaotic as it could have been. A lot of things happened to make this S3 incident go wrong. The triggering event was an engineer following an established playbook, typing a wrong command. It was a typo in the so this was a trivial error that triggered S3 to go down for not 5 minutes like we all expected, but 14 hours. The reason that it stayed offline for 14 hours wasn't that one command being entered wrong. It was a plethora of interacting problems that prevented Amazon from being able to get the region back online. A lot of us in the industry found out all the ways that we depended on S3. No one planned this, of course. No one was like, you know what, tomorrow let's take S3 down, see what happens. It was completely unplanned. So this incident illustrates a lot of the things that we're going to be talking about tonight. One of the aspects of this incident that was interesting at New Relic was our New Relic Emergency Response Force, which is a group of highly trained incident commanders who came together to help coordinate this incident. And it also showed what a great incident response process we have here at New Relic, which I just have to mention because having worked with a lot of customers and seen a lot of different companies in the industry, we really have one of the best incident response processes that I've seen. So we're going to unpack that a little bit tonight so you get a sense of what that looks like and then dig down underneath it. So incidents are very interesting. We're going to talk about why. We've been doing work with the SNAFU catchers. And again, show of hands, has anyone heard of SNAFU catchers, read the Stella report? Just a few people, okay. They've been doing research for the last handful of years on how tech companies cope with complexity, specifically around incidents. Richard Cook is one of the principal investigators. David Woods, who's been working in human-machine cognition for the last 30 years. He helped redesign nuclear reactor interfaces after the 3 Mile Island incident. He helped with accident investigations after the Columbia disaster. He's been doing amazing work. He's one of the smartest people you've never heard of. He's one of the principals. And then John Alspaugh, who people in this room may know, he introduced the concept of the blameless retrospective into the tech industry and has been shaping a lot of thinking around a lot of areas, is also one of the main investigators. So they're working with New Relic, IBM Whitewater, Salesforce, and KeyBank, as well as IEX, to unpack some of our incidents, have us get together in a room and talk about what goes wrong and how in our organizations. So I've been talking a lot about incidents. I've been talking a lot, in fact. What is an incident?
Now, is it green? It's solid green. Okay. There's a lot of different definitions of incident out there. OSHA has one. IEEE has another one. But basically, it is an event that is immediate and urgent, that is important to someone, that involves the responders going into an alternate mode in order to be able to handle it. And so this is kind of part of the sharp end, which is, we're all sitting in our chairs, our heart rates are low, but then when an incident happens, there's the tension and there's the immediacy of the resolution. And so that's true in the aviation incidents and in firefighting and in hospitals and being a surgeon or an anesthesiologist, and it turns out running software systems, incredibly complex software systems at scale.
So let's talk about some of the characteristics that differentiate incidents from day-to-day engineering, what makes them different. So there are 3 characteristics I want to highlight that drive the differences between incidents and regular engineering activities. The first is that they're high stakes. So a CSS bug that changes the color of a navigation menu, probably not an incident. A CSS bug that hides your login from all users, that's an incident, right? The outcome really matters. And so that in turn drives incidents being high cadence, which is a fancy way of saying time pressure. You have to get it resolved as quickly as possible. And what that means is that you're making different trade-offs. We make trade-offs every day in engineering. You make different trade-offs. You weigh things differently when you have that kind of time pressure and those high stakes. And then finally, very importantly for the work we do with SNAFU catchers, incidents are almost always group activities. You don't have one person slogging away trying to fix a problem. You have a group that's coming together to deal with it, especially the more interesting incidents that cross team boundaries and require a lot of collaboration. Collaboration is expensive. So the theme for the research that we're doing with the SNAFU catchers is the cost of coordination. How do you pay the costs of getting the resources that you need into the room in the first place? Every person that joins the incident, we hope, is adding something to the effort, but they also come with this overhead of an additional person to bring up to speed, an additional person to factor in. So paying those costs of this being a group activity is one of the things that we've been looking at. So let's talk a little bit about the New Relic incident lifecycle, just to get a little more concrete, and then we'll break down a little bit more academic view of how incidents unfold. So at some point, something bad is brewing. Maybe you've got, CPU usage is slowly climbing up, and then at some point it crosses a threshold and you have an incident, or maybe an S3 engineer hits the wrong command and boom, everything's broken. At some point, whatever was brewing gets noticed by a person, and we kick off an incident response process. If it's a problem that you can deal with through automation, then it's probably not an incident, self-healing, whatever. We're talking about something where humans have to intervene. So at New Relic, you would go into Slack, you type 911 IC me to take the incident commander role. That's going to kick off this whole incident response process. And then you go into the actual collaboration phase, right? You're triaging what exactly is going wrong, what could the problem be, people are coming up with hypotheses, sometimes there's false starts. At some point, you figure out what the problem is and how to solve it, or it magically solves itself, and you're like, okay, and you hope it doesn't happen before you figure it out, happen again before you figure out what the problem was. And then you declare the incident over. And then, of course, there's all this follow-up, right? There's what are our follow-up actions and the incident retrospective and all of those things that happen after the conclusion of the actual incident. So we've got time to detection. How long does it take you to go from something is anomalous to a person has noticed that? And time to resolution. How long does it take you to go from we've noticed the problem to the problem is solved? Now,
the industry buzzwords MTTD and MTTR are right there, and those are the measurements of those time, which is a really shallow measure of the amazing amount of complexity that we'll dig out of here, of variation and like all the things that happens. But it's the best the industry has to measure, or had. I think we're getting better now, but it's still a problem. So here is Richard Cook's model of an incident. And so this is a little bit more in-depth and detailed. Over here, you've got the contributors and enablers, which is a change in use. It can be a new interaction. It can be a customer who decides to take all of their staging and test and performance testing environments offline at the same time, and then bring them all online at exactly the same time 2 weeks later, which will trigger. It could be a new feature, it could be a new dependency, it could be a change in the system, it could be an outage of a power switch, it could be anything. But there's a whole infinite world of what could be the contributors and the enablers. But eventually, one of them, something, crosses a threshold, and that's the trigger. And then something fails. Boom, event. So after the event happens, the thing that triggers it, and as the system is in a abnormal and brittle state of failure, people recognize it. And so the pagers go off, the alerts go off, the CEO who obsessively checks the website says it stops working and calls down. Any number of ways that recognition can happen. And then we get going into the evaluation and response, which one of the things that we've done here that is amazing at New Relic but is part of the incident response, is having a shared sense amongst your organization and your people of when the trigger happens, when the page happens, what do I do? We have an emergency room Slack channel. Everyone knows to go in there. We know the outline of the playbook, and this happens everywhere where there is an incident response. How good is it? That's a different question between organizations, but there's a whole field of study just in how do teams organize and share playbooks so that everyone's on the page and not figuring out, hey, what Slack channel should we get into? Should we make a phone call? Should we do this? Should we do that? Every time, because those decisions in the moment are expensive. And again, incidents are about urgency and high cadence. So anything that you can have as a shared playbook ahead of time is one less decision you have to make in the heat of the moment. And then there is response and the immediate sense making. And so this is everyone trying to figure out what's going on. And in a lot of incidents, one person will know the Java code and one person will know the other thing, and it's piecing together this puzzle to figure out what the heck went wrong. After that, and again, in coordination, this conversation and this brainstorming session and this searching and this like investigating the system through observability tools and monitoring and checking log files and who knows what horrible tricks of SSHing onto boxes and doing whatever is all part of the cost of coordination, again, to be on the same playbook and have the same know how to interact with the humans trying to make sense of this incident. Okay, the incident's over. Now, let's have some formal and let's have some informal retros. We have a process where we have a retrospective, we get everyone in a room and we go through and talk about what everyone saw, the order of events, come up with a timeline. You might go and, have a happy hour drink with some colleagues who were involved in it afterwards and decompress, and you chat about, okay, so what was it? That's more informal retro, but it's still a collaborative event of, after the urgency has passed, looking back in hindsight and trying to make more sense of the entire incident process. And from these conversations and this sense making, we have memories, we learn. And so the conclusions that we come to and the ideas that we have there then feed into how knowledgeable we are about the system, how we know where their system boundaries are, fault tolerances, like all those things about the system we now know and we carry with us forever, or until the next time the event goes off and now we are more knowledgeable about the system and off we go. Postmortem.
Richard tends to use postmortem. We use the phrase incident retrospective, same thing.
So for just a moment, think about this. We all run systems, and systems are the things that fail. And so we're thinking about, in our case, the ingestion pipeline and the website and my controllers and my database and my SQL queries and all of those things that are, and our users and our traffic and our load, which is users in the real world using and interacting with our system. And we have all this complexity of code and processes running in production to serve their experience. And so this is what we usually think of when we think about the system. There is a big green line right here, which we call the line of representation. And so the things, everything that we see that's below the line of representation is some abstract picture that we have in our head of the server, the controller, the Java process. There is no thing that is a Java process. It's a process running on a computer. It's bits and bytes and electrons. It's not the tangible thing that sometimes and usefully we make in our head as we're modeling the system. But even that is not the system, because we have code generation, we have testing tools, we have deployment tools, we have organizational tools, we have monitoring tools, we have software-defined network layers, we have VPCs, we have it just goes on of all of the lines that you can draw from the simplistic view of my application, all the things around it that have to be there and have to be running have to be running and have to be in a good state in order for these people to be getting a good experience. So then, now we think, okay, now we've got a good view of what our systems are. Then we have these people, and these people are you and me. This is where the real work, the human work, gets done. And these people are getting stuff ready to be part of the running system, so they're programming. Here's the architect trying to think of the big architectural patterns. Here's some SRE who's setting up monitoring. It could be the people that need to go and update the status page if there's a deployment and interact with the customers. It could be the marketing people that need to know that a thing is live so that they can turn the other thing live. It's all of that. And if you notice, they all have different pictures in their heads because everybody has a different representation of everything below the line based on job role, what they're concerned with, how long they've been there, what's important to them. Are they in the reliability organization, the product organization? Just everybody has a different model in their heads of how the system works. And so the collaboration involved in the incident is everybody bringing their models and representations and trying to do diffs in real time to put it all together to get a working model of the system that fundamentally explains what the incident is. And so this is where, above the line, is where the real world, the work happens, and below the line, we think it's tangible, but it's just bits out there, and it's far away from us, and there is no way to know all of it. Our models must be faulty. They might be useful, but they are faulty.
So one of the ways that we cope with this world where we have these technical systems that we can never actually interact with, we're always interacting at a remove through these other tools. The way that one of the tools that we use to synchronize our mental models of those systems is the incident retrospective or the postmortem. So this is something that became sort of a de facto standard a number of years ago. You have an incident, and how many people here in any kind of organization where you have something go wrong and you have to do some kind of incident retrospective or postmortem? Right, okay. So this is normal for us now, right? Retrospectives are great, and they are a way for us to say, okay, something went wrong, we need to learn from this. So we're going to have this process. We're going to get everybody into a room, and we're going to talk about what happened. We're going to come up with follow-up actions, and then we're going to have learned about the incident. And this is great, and it is a useful tool, but it's insufficient, and it's subject to a lot of pressures. So what are some of the vulnerabilities of the incident retrospective? The first is what Richard calls the post-mortem cycle of death, which is what probably some of you will find at least a little bit familiar. We're all under production pressure, right? We have pressure to deliver more features, to improve performance, to improve reliability, all of these things. And so that pressure is this constant force that nudges us to skimp a little bit. We're constantly making this trade-off. How much time and energy do we spend comparing perspectives and talking? And how much time do we spend doing the real work that we're going to get promoted based on, right? So we skimp a little on the retrospective, and the depth and breadth decrease just a little bit on the actual process. And so we don't get quite as much out of it. And so then the people who show up are like, that was kind of a recap of what happened rather than a useful unpacking of lessons. And so the next time they go to a retro, they're like, the last one wasn't that useful, and the one before that wasn't either. And so then the person who's preparing the retro, of course, responds to that, and it's a feedback loop. And eventually you get retrospectives that are busy work. It's like, how quickly can I fill out this form and get back to my real work, right? That's the unfortunate end of this spiral of death. So what are some of the antidotes to that? Well, they're not easy because they involve counteracting a lot of powerful forces. We're going to talk about those forces in a number of the upcoming comments. But one of the things that we've done through the SNAFU catchers is introduce a more in-depth process of learning from incidents that we bring to bear on carefully selected incidents. We don't say you have to do this for every single one, but we do introduce this for specific incidents that we think are high value, very interesting. One of the incidents that we did an extensive process on, we selected because it wasn't too severe. It didn't have a lot of emotional charge around it. If you pick the really big, bad, hairy incidents as the thing, okay, we're going to really study this, everyone is like, oh, no, I'm not going to touch that. Don't interview me, right? You pick something that's interesting but a little less pressure, people are like, oh, sure, I'll talk about that. So that was one of the criteria. We look for incidents that involve a lot of people, especially people from different teams. It's cross-team dependencies, super interesting. Collaboration, right? And so what we did was we selected a couple of different incidents and we went through a much more in-depth process. This involves something called process tracing, which we've been learning from the folks at SNAFU catchers. And so at the center here, you see we've got this official postmortem document, right? This is the canonical document. You have the retro, you create the document, everything has been done that is supposed to be done. But around that is all this other activity. So there are interviews with participants from the incident where you get somebody to say, hey, could we talk for half an hour or an hour? And I just want to ask you some questions about the incident. Yeah. Oh, thank you. Great question. So the question was, is this concerning incidents that are internal to New Relic? And the answer is yes. We've been focusing this internally for now, looking at incidents that we've had and understanding how we've coped with them. So we'll interview participants. We'll get people from the outside to help us analyze. So again, this is the work with SNAFU catchers, getting experts to come in and look at the artifacts that we've generated and help us to understand how to study what is happening and give us that external perspective. We're fortunate to have really good transcripts of our incidents. You learn a lot from just looking at how many people were there, when did they appear, how many utterances did they make, how many times did they type something in Slack, what was the flow of people in and out of the incident, what were the severities that were declared, did it start as a Sev 5 and then peak to a Sev 1 and then drop again, was it spiky, what did the severity profile look like?
We also have a really great advantage because we are New Relic. We instrument the queries that we make, the NERCL queries that we make as events. So we can also go and query all of the queries that everybody typed while they were responding to the incident. So then we can go, oh, what were you doing there? What's the purpose of this? What's the question you're asking there? Which is another part of the feedback loop of you learn a lot about how to use New Relic by watching how other people use New Relic in the incident.
And spoiler alert, Tim is going to talk about hindsight and how it's not 2020. And things like that are great for interviewing people because it sparks their memory where they're like, oh yeah, I did this and then I did that and then I did that. And then you show them what they actually did. They're like, oh, right, no, that's completely wrong. Here's what I actually did. And it gives you a lot more insight into the reality of what was happening in that high pressure situation. So all of this, and I'm not going to dive into this too much longer because we need to keep moving forward, but all of these different ways of gathering information about what actually happened and then making sense of that information can really help you to dig deeply. And the challenge with postmortems or incident retrospectives themselves and with deeper processes like this is that you're always weighing those trade-offs. It's going to take us time and energy to do this work. Are we getting a payoff from it? Are we getting a return on that investment that makes it worth putting the time and energy in the first place? And answering that question is very difficult, but doing a few more in-depth things like this can give you enough depth of value that you can both justify doing it and you can also learn how to tune your other processes so that they're more productive.
So the root cause fallacy. We believe this is insufficient, and as do the SNAFU catchers, although it's everywhere. So why? The root cause fallacy is basically saying X caused Y, even though in reality, X contributed to Y, but so did A and B and C and D and E. And if any one of those things hadn't been true, there wouldn't have been the incident. But it was the one that changed last that we go, aha, that's the root cause. So when you lose who's lost their keys before? Why is it that your keys are always in the last place that you look for them? So there's a model, the latent failure model of complex systems, or the Swiss cheese model, which basically says in an organization or a system as big as you can be, at each layer, there are defenses against issues. So on the finance team, they double check their math and they make sure that the numbers all line up. The engineering team writes tests. The QA team goes and evaluates. We have trainings, we have retrospectives, we have all these things all the way through. We have checks and gates on deployment. And in order for something to get through and cause one of these incidents, it looks like a string of coincidences. Oh my goodness, it was so lucky that this just happened at and in order for the incident. But through this model, and I don't remember who originated this, there's a lot of work and models around understanding these because there is something to be learned at every single step along the way that led to this incident, because any one of these capabilities could have done something different that might have stopped the incident before it happened. Hindsight bias. Hindsight bias. Hindsight is not 20/20. It takes things that had been flittering ideas that just maybe passed through your head and turns them into, I knew that was going to happen. I knew it, with a certainty and an absolute confidence that was not present going forward. So one of the challenges in running more complex, the deeper level of incident analysis, is making sure that we walk people through the transcript from the beginning, step by step, so that they're rebuilding the context of the incident as they go, and not allowed to just go, oh, I know what happened there. It was this, and this. Can I get a lunch now? And there's other forms of group hindsight bias, which is If your chief architect was involved in the incident and is sitting there in the middle of the retrospective, and the chief architect says, X is what caused Y, and here's what happened. That's pretty definitive, right? But that's another form of hindsight bias of a group, because that is just one perspective. And we just showed in the Swiss cheese model, all perspectives are different. All understandings of what's below the line is different. And so to really understand how the group thought of the incident, you need more than just, it's a warning. It's a warning not to let one particular model for any number of reasons dominate, and not to allow faulty memory to get in the way of asking the questions about the state of the world and the people and the teams in the moment when they were making the decisions.
It's a little bit outside of our scope tonight to talk in detail about the concept of human error, but neither one of us can let an opportunity go by to talk about human error, so we're going to cram it in here. So Gary Klein has a great book called Sources of Power about some of his research into naturalistic decision making, and he talks a lot about looking at accidents in very high pressure situations. One that he goes into in great depth was a case of a military ship shooting down a passenger airline by accident. We're talking about pretty much the worst incident you can imagine. And he reconstructs this incident in great detail, and the immediate accident report after that event cited human error and was very susceptible to this hindsight bias of looking backwards and saying, look, it's obvious what should have been done, when this was the experience of the people in the moment. They were dealing with terrible user interfaces. They were dealing with pilots who were doing unexpected things because they were confused. There was this whole panoply of reasons that contributed to the confusion. Everybody in the scenario was doing their best, making the best decisions that they could make with the information at hand. And the accident investigators, of course, came in later. They were not at the sharp end. They did not have this complete model, and they made very different attributions as to the cause of the problem.
Once you see this, you see it everywhere. Like the CEO of Equifax, when everything got breached, said it was human error and it was one operator's fault. But going back to the Swiss cheese model, okay, so here's an individual making the change that caused the opening for the data loss, but could there have been a check before that? Was there a team around that also could have done it? Was there an alternate way that they could have stored? I mean, it just keeps going. And so to say that it is the fault of one single human, A, is unjust, and B, leads to the thinking, well, let's just get rid of that human and we'll get a better human in, and then we'll be all right. But that does not mean that it won't happen again, because people are products of the system that they are working in.
The S3 incident was a good example of not attributing to human error a big problem. They did not blame the engineer that typed the wrong command. They didn't send them for retraining. They said, you should not be able to hit enter at the command line and take down S3 US East 1. If you can do that, there's a bigger systemic problem. That's the problem that we need to solve. So let's talk a little bit about boundaries and safety culture. So we all have these mental models of the system. They're shaped by where we operate. So engineers are operating at this safety boundary. They're dealing with the potential problems that are going to crop up. And if you ask an engineer, okay, are we going to have an accident? Are we going to run out of money? Or are we going to run out of enough engineers to do the work? What are they going to say? They're usually going to say, we're right here. We're like near the boundary. Something's going to go wrong, because they know how close we are usually running to failure, because all complex systems run as broken systems. They always run in degraded mode. We're always near the edge of failure. Now, if you ask an accountant, well, they think we're just about to run out of money because that's their sharp end. That's the problem that they're facing day to day. If you ask our recruiters, what is our biggest problem? It's like, well, we don't have enough people. We need more engineers. We have 44 open recs. Like, we've got to fill these. So one of the problems that a good safety culture solves is this disparity of models. Now, one of the defenses that we install against this problem of operating too close to the boundary, if you imagine the system is like, this is safety, right, in the middle, and out here are different failure modes. So we're running in here, and we're sort of this like Brownian motion where we're like getting a little bit close to an accident, and then we pull back, and then something sends us over the edge, and everybody freaks out. And so we do this thing where we introduce nominal boundaries, right? This is very common in a lot of engineering disciplines, right? Your engines are running at 100%. Well, it's not really 100%, because you know you can run at 110%. You can probably get away with running at 115%. So one of the problems with nominal boundaries is that you install them and you're like, okay, this is the new boundary. And so you start operating inside of that boundary, except you kind of know that it's nominal, so you start to push a little bit. And this is one of the things that led to both Challenger and Columbia explosions, right? There were all of these nominal boundaries, and there were all of these production pressures, and each of the boundaries on all of these layers of the Swiss cheese kept getting pushed and pushed and pushed and pushed until enough of them get pushed, there was a critical problem, and there was a disaster. So what safety culture does, because those nominal boundaries are always going to get pushed, and because there are always these pressures, especially from finances and resources, safety culture allows for these different models of where we are in the safety zone to begin to converge by allowing conversation. This is one of the underpinnings of DevOps, right? It's like, let's stop siloing everybody. Let's get people who have different views of the world into the same room. If it's not the same person, at least they're on the same team and they're talking together, they're comparing mental models, and they're going, oh, if I do this, that will happen? Yes, that will happen. Well, we shouldn't do that. No, we shouldn't. Those conversations start to cluster everybody into the same zone. You also see this, for example, in conversations between different parts of the organization. Finance says, we're going to buy you hardware quarterly, and engineering says that's not how computers work, and that's not how capacity works. And so eventually you find someone in finance and someone in engineering who can talk the same language and say, okay, well then let's buy a bunch of stuff up front, and let's work out a deal with our vendor, and let's release the machines at the pace that you need, and now suddenly you're able to solve the problem, not because you didn't have the money or you didn't have the engineering, but you didn't have people comparing those mental models and working out tractable solutions to the problems. So this ability to have transparency and communication among people with different models is one of the cornerstones of a good safety culture that lets you operate in that safe zone. We are actually on time, I'm amazed. So let's recap a little, and then we'll open up for discussion. So incidents, as Adaptive Capacity Labs is the consulting arm of the folks that do SNAFU catchers, and their motto I've stolen because it's so good: incidents are unplanned investments. You can think of them as a product of human error, which hopefully you won't now. You can think of them as just something that's a pain that you have to deal with. Well, they're a pain, and you do have to deal with them, but they are very valuable events if you know how to make use of them. So they can, if you use them well, show you where to look. Our complex systems are fundamentally unknowable, right? There's no possible way that we can fully comprehend these systems. So incidents help us look at the areas of the system where we can most productively investigate and dig into that complexity. They help us to think. They surface where those mental models are incorrect or miscalibrated, because no matter how good our mental models are to begin with, change is constant, So those models are going to become outdated pretty quickly. Incidents help us constantly recalibrate. And hopefully incidents can be motivators to act wisely. They can be a force in the organization to help calibrate those different models of where we are in the safety zone, and they can help us get the resources that we need to do the work that is usually avoided because risk is typically invisible in the system. Incidents make the risk momentarily visible and help people say, oh, we need to invest here. This will be hard to read, but there are some links at the end of this presentation, which I believe will be made available online with some additional reading if you're interested in any of the topics that we've been talking about. And
there is so much in this field and in those books that is Ward Cunningham works. So before Woods has a model that he's coming out with called graceful extensibility, the theory of graceful extensibility. So we know there are organizations and systems that are resilient. What do they all have in common, and how do you build one? And Cunningham works here, and he's called it more agile than agile. And the current, soon-to-be buzzword is resilience engineering. But some of these are from, everything on here is amazing, and Sidney Dekker has a book, Just Culture, where he asks the question of what makes a culture just and the rules just, and who gets to draw the line for whether someone's behavior is appropriate or inappropriate. So going back to the human error, that is a manager way up, away from the sharp end, looking down at the actions of someone on the sharp end and judging, saying, they messed up, they didn't do it right, they're bad. Where he has a whole model and a ton of evidence and a whole amazing world of evidence and models about the lines are best drawn by people doing the same class of work. So people who do this work every day should be the ones to draw the lines to say you're doing it good and you're not, because they're the ones who know. Anyway, this whole reading list is amazing. It's amazing.
Questions, comments, what do you got?
I have a mic that I can pass around to folks as well.
We've answered all your questions. No, good, okay.
Kind of a out there question maybe, but have you heard Edward Tufte's explanation of the Challenger design? So is that bias at the end, or how do you explain, and maybe you could even talk about.
Yeah. So quick recap. So the generally accepted explanation immediately after the Challenger explosion was that these engineers messed up by not announcing properly that, other way around. The management messed up by not listening to the engineers and not canceling the launch. And Tufte breaks this down a little bit with a little bit more nuance and talks about the effectiveness and lack of effectiveness of communication between the engineers, and has a much more nuanced lens on the reasons for the explosion, which are really worth looking at. I think it's in the visual display of quantitative data. Yeah. So great book, great breakdown of a really interesting and terrible event. It would be interesting to get Woods' particular perspective on that, but I'm going to say that the Tufte sort of pulled things back a little bit more. The key thing is that the explosion itself, that lack of communication between the engineers and management was one of the layers in the Swiss cheese model. And so, yes, it was a factor, but the whole notion of there is a root cause, like that's the thing that you kind of have to just throw out, and then everything else falls into place. That was a layer in the Swiss cheese, but there were all of these other layers that was necessary but insufficient. There were all these other conditions that were necessary. Does that answer your? Yeah. Mm-hmm. The media blamed the O-ring. Yep. Yeah. Yeah, and if any of you get SRE Weekly from Lex Neva, this week's issue has a fantastic article about, I can't remember the title of it off the top of my head, but I think it's the second article in this week's newsletter, talks about some of the cognitive effects that we're discussing and discusses Columbia and Challenger.
So I was wondering, in analyzing this sort of Swiss cheese model, I mean, because there's a root cause is where one thing that caused the problem, but isn't there the character of this particular Swiss cheese which is what caused the problem, right? Like, is there a sort of more topological view of the whole sequence of things that you could derive some value from?
So there's...
Probably.
Go ahead.
Probably. I don't know what it is, and kind of what we're finding is that every incident is so fundamentally different that the only generalization that can be made about understanding incidents is that you have to be close to it and you have to pull it all apart and you have to look at it. That all of our efforts to like generalize these things broadly up until now have failed, except we look at the experts in the system at the multiple layers and go, hey, these three people all were really close to it, and their model together puts them, but it's every incident is different. And then onto that, there's a danger in making the assumption that this incident looks just like all the other incidents. Oh, okay, fine. But there might have been one thing that was totally different about this incident than all the rest, and that might be really interesting. So, like, one of the challenges of studying incidents deeper is getting overwhelmed with data and models and options and just the complexity of it. So, someone there would probably be able to answer it. I could answer that more specifically here, but it's hard to generalize that, or at least at my level of understanding. Maybe Woods would have a better understanding, but no, and maybe.
Two comments that might get at what you're asking at. One is that it is useful to talk about triggering event. Like, we do track what was the triggering event, because that is useful and interesting, as long as you don't mistake it for a root cause. And have that be the end of your investigation. I think one of the articles I linked to is John Alspaugh's The Infinite Hows instead of the 5 Whys. And one of the points that he makes is, look, you could go, like, it's turtles all the way down, right? Like, you could infinitely investigate any event down to the molecular level. The question is, what's useful? Back to, there's always a trade-off. At what point are you getting into diminishing returns? So there's like a class of incidents where it's like, this was the triggering event. Yes, there are other causes. No, we don't care about them. And then there's other events where you do care more, and the trick is learning to distinguish. There was a question over here, actually, I think, right to... I can repeat it back. I feel like I unknowingly planted you because those are both two of my favorite topics. So your first comment was about chaos engineering, the work that Netflix is doing with Chaos Monkey. That's incredibly relevant, and that Casey Rosenthal and Nora Jones, who are both founders of chaos engineering, have gone through the Human Factors and System Safety program that John Alspaugh went through, that Sidney Dekker started. I mean, this is all of a piece. So it's not a coincidence that you make that connection. And the discipline of chaos engineering is built on this notion that if incidents are unplanned investments, well, then why don't we plan the investment? Then why don't we push and create the incidents proactively in ways that we can control and maximize the return on? So yeah, this is the foundation for what chaos engineering is. And then your second point about novel incidents and the role of intuition, I have a whole other set of talks on the topic of what we've learned from watching our NERFs. I mentioned our New Relic Emergency Response Force earlier. And the NERFs, as we watch them and other systems experts interacting with the system, we learn how experts build their expertise in the system and how they build intuition. And one of the things Richard Cook talks about, for example, is the ability of experts, whether it's an emergency room doctor or an experienced engineer, to walk into a critical problem and say, this is what's going to be happening in 10 minutes if we don't change what we're doing. And that might be a good thing, it might be a bad thing, but they've built such an intuition based on their depth of experience that they can see into the future a little bit, and they can be like, why don't we try this? And they don't know why. And that is one of the reasons that misunderstanding the role of automation is so deadly. Because if you think that you can just automate all these problems away, you're not understanding the different classes of problems, and that intuition, I don't think in my lifetime we're going to be able to do away with those experts.
There's another interesting thing that's come out of the study of those experts is not only are they expert at putting their finger on it, they're also expert and more likely to go, I have no idea, rather than offer a hypothesis and be wrong. They know where the limits of their expertise are, and they know intuitively what's beyond it, and they know intuitively what's on the edge, and they know intuitively what's within it. And that's like, how does that work? I don't know.
And they know the people that are at those boundaries, because again, they see humans as part of the bigger system.
I was going to ask about the chaos monkeys, but since that's been done, I'll ask a different question. So you've done all this work internal to New Relic. Where are you going next? Are you working on products? Are you working on consulting with companies outside of New Relic, or where do you take this from here?
This work has had a lot of deep influences. One of the things that it's shaping is the main thing that it's shaping is how we learn, and it's changing how we have discussions internally about, okay, how do we need to learn from incidents? How do we tune our retrospective process so that it becomes more valuable? There's discussions, the safe harbor slide earlier is making me a little touchy to go into too much detail, but there's a lot of conversations happening as a result of this collaboration about, sort of across the board. One of the tricks to the SNAFU catcher's work is that it is on that less immediately visible end of the investment scale. And so one of the challenges is really understanding how it's shaped and influenced us, because the ramifications are so broad. But do you have anything to add to that?
You know the conscious incompetence model of you start off unconsciously incompetent, you don't know what you don't know, and then you're consciously incompetent, you know that you don't know, and then you're consciously competent, like, okay, I've got this, I know what to do, and then eventually someday you're a master and you're unconsciously competent. it is so clear that we are still, like, some people might be in the consciously competent. I'm clearly in the consciously incompetent. And so there's this whole pipeline of cost of coordination and communication that is ripe for experimentation and going, okay, can we get those 4 people in different departments, which we can't co-locate them and sit them together on a cross-functional team with the finance director, right? That's too expensive. Can we do a 30-minute risk brainstorming where the outcome is a risk matrix and get all of those people in there, run it fast and efficient? Is that valuable? So far, yes, that is. But anywhere along that pipeline, it's ripe for optimization and analysis and trying to figure out what's next. And the complexity is just, it's huge. Another one is, after the incident, here are the queries that you ran. Let's talk through these and document them and put them somewhere. I mean, it's just every stage along that either gets the detection faster, gets the resolution faster, gets the learning more distributed in a more effective manner. Like, I've learned so much about Cassandra by doing these because I'm talking with experts who are like, oh yeah, I did this. I'm like, oh, if I had known that, so like, there's just so many paths. It's nearly infinite. Oh, sorry. Good, yeah.
I was wondering, nowhere you mentioned probabilities and trends leading to these incidents. I've been involved in looking at the incidents and defect rates in manufacturing, and it's the same thing, right? So you were kind of tracing the path of the incidents and the failures. Usually they correlate with quality. There's low level incidents happening which don't cause these big failures, and they usually correlate with with the big events you were talking about. Is that something you follow, or you just didn't want it to go into this topic?
Are you asking, do we follow the process from industry?
My first answer is I don't know enough about the intricacies of the manufacturing approaches that you're talking about to answer in great detail. My second answer is I think that in software systems, we have a class of incidents that mirror what you see in manufacturing, where I think things are a little bit more deterministic. Is that a fair assessment? Okay. Yeah. Mm-hmm. Yeah. So with software systems, we're dealing with very non-deterministic problems, and Again, I don't know enough to know if the probabilistic approaches would be useful for a large set of our incidents, but I think there's a set that would be difficult to apply that to. I wouldn't say that. I think that we're dealing with some incidents that, for example, the kinds of incidents that are now being tackled by AI ops, where you're able to apply machine learning and actually see certain types of failure modes and predict them and be able to anticipate them. I think that is relevant, but then there's other classes of incidents that fall outside of that, that aren't as tractable using those methods. Right. Right.
So the multiple layers of Swiss cheese makes sense. There are multiple areas of failure that allow certain things to get through. If you were to apply that to healthcare, you know there's always going to be disease and death. And so which layer would you fortify? Do you provide more doctors? Do you exercise more? How do you draw that balance? And how do you deal with a situation where you don't have complete answers? Because I don't think we'll cure disease in the next 30 years. We'll fight back a lot of it, but
No, I would agree.
Is there a situation where you do have complete answers? Because in this, there is not a state of complete answers. In this system, there is no God perspective that knows all the things. And it's in dealing with the models of complexity comes the assertion and belief that there is no way to know all the things. It is not knowable. But to go, it's hypothetical. It's not our field. We talk with someone who it is their field, and like his examples of also, there was one hospital in Cleveland that threw all of their eggs in the freezer away that they had for fertilization and patients. Okay, so that's pretty traditional, and that would fall into that. But then if you're in the ER and you've got a patient who is 75, has had cardiac problems, has low blood pressure, and is now bleeding out, like there is a weird, almost Swiss cheese-ish convergence of all of these different vectors that the operator needs to have the experience and judgment to, at the end of the day, guess what the right thing is. And that goes back to there's not human error, and the best person to judge one of these operators is another operator, and the organization needs to have their back because like that's hard. Like this is so hard, the complexity that people just don't know. Does that make sense and close to where you were asking, sort of? Oh, go ahead.
If we look at like the pharmacy industry, right, how many years it actually takes to ship a product to the public? Many, many, many years, and gates and checks and counter checks and counter checks and counter checks. So, but with our software systems, we, as a collective, as a business, choose to, turn off some of those safety switches for speed. And, so I think part of it is, we could learn more about the system, have a bit closer to that God perspective that you said, but with the trade-off of time and massive resources and money and time, which would, at least in the SaaS product game and the internet speed, so that we need to all execute on, we choose to forego some of that for speed.
Also, hospitals in critical surgeries have taken their incident rate from abysmal to pretty bad by having checklists. And the surgeons fought it because they thought, I know everything. You don't need to give me a checklist. But then they would make mistakes, and there would be confusion between them and the nurses. And so pulling from the aviation industry, where there's checklists everywhere, there are now checklists that surgeons and the whole operating room need to go through, which is a low-cost way of paying the cost of coordination before the procedure to make sure everyone's on the same page and to respect everyone's opinions that everything has been done, rather than relying on just one single voice of authority that, oh yeah, this is good, let's go. So there in the Swiss cheese model, that's one up from the practitioners. That's in the team organization of having a coordinating checklist because they have the time and the stakes are that high.
How important is the timeliness of a postmortem?
Huge.
So important, yeah. We require high severity incidents to be to have their retrospective within, I think it's 1 business day, which gets, again, production pressure. There's constant pushback. It's like, we have other things to do, but that immediacy is really important.
And we totally see evidence of people forgetting all kinds of stuff all the time. And like, you can read stuff about how juries are notoriously fallible. And I think there's even a show about getting the facts 24 hours or 48 hours after a crime. And we see the same thing, just like people forget, or people are more likely to go with one answer and have that kind of cemented in their brain rather than the multi-view, epistemologically plural answer, which is a word that comes out of this research that I thought was awesome. Epistemological pluralism, multiple ways of knowing about the thing rather than just one.
You folks mentioned that you do interviews, and Tim, you mentioned something about context reinstatement. Do you guys use cognitive interview techniques in your interviews, or is there a specific approach that you do to help that?
Part of me wants to say, how would you do an interview without a cognitive, without an approach?
Specifically the techniques labeled cognitive interviewing, like the ones used by like US accident investigators. Do you follow their same model?
Wouldn't say that.
So the way that we do interviews is we copy Richard Cook as closely as possible, which is, I mean, it's humorous, but it's accurate. We're apprenticing to him, basically. So I am quite sure that he adapts from that model because he's been doing this for so long. But he's also customized his approach based on what he finds be the most effective. So again, I wish he were here. He could answer in great detail and crossing multiple fields, but.
And one little piece of that, like one little nugget that proves invaluable so quickly is the difference in answers you will get from asking someone, what happened yesterday? And something like, okay, the pager just went off. And now you see this line, and now you see that line. Or in brainstorming risks, going, you are about to commit this line of code right now. In the incident, days from now, when you look back, what was the thing that started it? Because there's something weird about taking them in time and then looking back that gives you a richer set of hypotheticals than in the moment going forward.
I feel like you're channeling John Allspaw right now.
Oh yeah, totally, totally.
Thank you.
For the rest of
I just had a quick question. You mentioned that you have an emergency Slack channel, like war room channel for your incidents specifically. What do you do when you have 2 incidents?
We have 6 of them. We actually do have 6 of them. And then we've got, 4 urgent cares. So we've got steady state
ERs. We have 3 ERs? Anyway, we have multiples.
Yeah. We have multiples.
You can tell engineers were quibbling over how many emergency rooms we have, but yes. And that is actually, that's an interesting point because there are different ways of doing it in the industry because some organizations have one Slack, people who use Slack will have one Slack channel per incident. And there are actually, there are interesting differences in coordination between those 2 approaches. Oh no. Yeah.
Last one, us two.
In your emergency channel, do you try and follow a thread, or do you just do it in the channel as a whole?
Yeah, it's in the channel. We have an incident commander who is paying that cost of coordination by keeping everything flowing. So we have an incident commander. If it's a high enough severity incident, we have someone from support who's the representative in the engineering channel, and then going back and coordinating with support as needed. But it's a free-flowing discussion. There might be a little bit of threading on a specific topic, but it's just, yeah. And so then you'll get a transcript from a specific incident, header footer. You can extract that, and then the next incident to happen in that room, next series of messages.
So I'm not an engineer, so the biggest takeaway I had from this is how much more it humanizes the people involved in the incident. Do you feel that by looking at things as a series of triggering events instead of just somebody who needs to cover something, that people are able to be more vulnerable and authentic in the recall process and in handling the incident triage itself?
Yes, absolutely. And I mentioned it before, but the book Just Culture is the one that most captures the essence of what you're talking about now. And it only looks at how do you make a culture where people are not blamed, are not victims, and are respected, and that the decisions that are made by the organization meet a criteria of justness, which half the book is defining what does just mean. But I can't recommend that book high enough.
Yeah. When Richard and John came to New Relic to kick off this collaboration, they talked about wanting to restore the dignity of operators. And I was like, all right, I'm on board.
All right. Thank you so much, everyone, for all the great questions. Join me in a quick round of applause for Beth and Tim.